100 years after people. The sound of snapping steel reverberates down the corroded canyons of New York City. The cables of the suspension bridges connecting Manhattan to Brooklyn and Queens are disintegrating. The roadway of the Brooklyn Bridge is held up by just over 1,000 vertical suspender or hanger cables, each about the thickness of a human wrist. Each cable is made up of 7 strands of steel twisted around each other, a total of 100 miles of steel in every cable. The cables are galvanized, covered in a protective coating of zinc, which corrodes much more slowly than the underlying steel.
This is a wire from a cable from an existing bridge, a hanger cable. And you look at the condition of the cable. You can see the paint is peeling off, and you can see that there are places where there's red rust. That means that the coating on these wires, which are mostly galvanized coating, the galvanizing is failing. And so now you have a wire that's going to rust, and you may have failures by fracture of individual wires. Once you've broken enough of the wires, then you begin to break wires as kind of a cascade. And you'll see them fray, and then the rope will fail.
Arching across the water, 2 bridges, the Golden Gate and the San Francisco-Oakland Bay, are strangely silent. In the time of humans, the Golden Gate was an engineering marvel, crossed by 108,000 cars every day. But 2 days after people, the only thing crossing the bridge is a single, silent assassin.
San Francisco's greatest landmark will die by fog. The moisture that's in the fog itself, condensing on the bridge, will promote the formation of rust. So, in a very real sense, the fog may steal in on little cat feet, but when it comes to a steel structure, it's a tiger.
"100 years after people. The crucible steel of the mighty Golden Gate Bridge has been humbled by common oxygen.
What you're talking about is a bridge that is painted rust red now. Years from now, it's going to be rust. May very well be the same color, but when you get close, it's not going to be a healthy place.
Dense fogs feed the rust, which threatens at the point of highest stress the vertical cables that bear the crushing weight of the deck.
The roadway is not designed to support itself. It's really designed to be suspended from these cables.
The failure of one cable quickly triggers others around it. Unsupported, the roadway plunges 245 feet into the chill gray waters of the bay. It's now 200 years after people. Only the skeletal specter of the Golden Gate's soaring towers remains. Nor are there any lorries to shuttle cargo over the Ambassador Bridge into Canada. "150 years after people. When it opened as a gateway to Ontario in 1929, Detroit's 1,850-foot-long Ambassador Bridge was the longest suspension bridge in the world. In the time of humans, this was the busiest border crossing between the US and Canada, carrying 25% of the goods, the majority in car parts, traded between the two countries. But as the vertical suspension cables give way, nothing will ever cross this bridge again.
Those vertical suspension cables are exposed to the wind, exposed to the weather, and they vibrate quite a bit in the wind. So they're a major wear area and a major maintenance problem for any keeper of any suspension bridge.
But in a life after people, there is no one to repair the frays in the vertical cables.
The weak spots are basically down at the bottom of the cable where the cables actually tie into the deck.
The vertical cables lay over one of two horizontal white lines known as catenary cables. 37 steel strands, each about a foot in diameter, interweave to form just one of the catenary cables.
As multiple cables break, it actually changes the shape of the white catenary cable that holds the whole thing up, because it's no longer taking an even amount of weight at each interval.
Another vertical cable snaps, and a segment of the deck crashes into the river. A 150-foot gap now gashes through the road to Canada. Within seconds, the other sections fall. "200 years after people." On the skeleton of the Ambassador Bridge, the white horizontal catenary cable that once held up the span is now helping to topple its remains.
That big cable is anchored on either side, on either shore. And when the deck is no longer there, the tension will be uneven. The big vertical towers would bend toward the land side. The tops would spread apart, and that would put quite a bit of strain on those towers.
The towers finally yield, and the last vestiges of a great transportation link disappear.